Hello students, very good evening. Today we are going to solve questions of ICC Board Physics, previous year questions, chapter Refraction of Light. These are, first we are solving 1 mark question. This is objective question. When a ray of light travels normal to the given surface, then the angle of refraction is, solve it. When the ray of light travels normal to a given surface, the angle of refraction is 180 degree, 90 degree, 0 degree and 45 degree. So you have to find out the angle between them, means angle always measured with normal. When you keep this angle on the normal, it will fall perpendicularly to the normal, means it goes 0. So I will be 0, R will be 0 and it will go undeviated. What will happen? It will go undeviated and the answer is 0 degree. यह ICC बोर्ड 2023 में आया था. While entering, next question, while entering medium A to B, if the light slows down, then you have 4 options. When light travels from medium A to B and it slows down, वो क्या बोलता है कि जब लाइट A से B में जाती है, मीडियम A to B slows down, then 4 options हैं. Angle I is equal to angle R, angle I is greater than angle R, angle I is less than angle R, angle I is greater than or equal to angle R. ऐसे करके 4 options है. तो मैं देखता हूं फिर से. When light enters from medium A to B, if the light slows down, then angle I is less than angle R, angle I is equal to angle R, angle I greater than angle R, and angle I is less than or equal to R, means not greater than, less than or equal to R. So you have 4 options. So how you can understand this question? When the question will be asked in competitive exams or objective questions, you need to understand the question. When light travels from medium 1 A to medium B, the velocity decreases. What he is telling, velocity decreases, means this is the rare medium and this is the denser medium. When the light coming from rarer to denser medium, this is the angle of incidence, rarer medium to denser medium, it bends towards normal due to decrease in velocity. So they didn't tell you about the rare or denser medium, but they given you idea about the decrease in velocity. So when the velocity decreases, when velocity will decrease? When it travel into the denser medium. So light bend towards normal. So this angle is small and this angle is larger. So angle I is greater than angle R. Option will be correct. So angle I is greater than angle R. This option is correct. So second question we came to know this option is correct. So you solve along with me. You solve when I am solving questions. You solve with me. Third question. The ratio of velocities of the light of wavelength 400 nanometer and 800 nanometer in vacuum. Velocity of light of a wavelength 400 nanometer and 800 nanometer. Okay, traveling in vacuum. So question I am going to discuss the ratio of velocity of light of wavelength 400 nanometer and 800 nanometer in vacuum. the ratio is 1 is to 1, 1 is to 2, 2 is to 1, 1 is to 3. 1 is to 1, 1 is to 2, 1 is to 3, and 3 is to 2. These are the options. So, what happens when light is traveling in vacuum or air, means air or vacuum, when light travels, all light coming together with the same velocity. So, there is the same velocity of this and same velocity of this. When it travel in another medium, the velocity changes because velocity is directly proportional to wavelength. If velocity decreases, you can decrease the wavelength. Okay. So, velocity of red light is always greater than velocity of violet light or blue light. Here, this velocity v1 and this velocity v2 both are same. v1 is equal to v2. So, lambda 1 upon lambda 2 is equal to v1 v upon v. You will get answer 1 is to 1. And 1 is to 1 is the right option. So, this question you came to know, in air vacuum the velocity is same of all colors, but in medium changes when it travel in any medium like water. When goes in water, the velocity lowered. Okay, velocity lowered. So, velocity is directly proportional to wavelength. So, wavelength of red is greater than wavelength of violet. When the velocity of red is greater than velocity of violet. So, that is a different case in any medium. But here we came to know the velocity ratio is 1 is to 1. Next question, the refractive index of diamond is 2.4. It means that, well, the refractive index of diamond is 2.4. Refractive index of diamond A mu D, refractive index of diamond with respect to air is 2.4. Refractive index of diamond is given. They have given you 4 options. The speed of light in vacuum is equal to 1 by 24 times the speed of light in diamond. Light in diamond is 2.4 times the speed of light in vacuum. Speed of light in vacuum is 2.4 times faster than the speed of light in diamond. The wavelength of light in diamond is 2.4 times the wavelength of light in vacuum. So you have 4 options. So first I will write the formula. A mu D is equal to velocity of light in air to the velocity of light in diamond. Okay, this is given 2.4 is equal to VA upon VD. Okay, so velocity, what they have asked, we have 2 options. Velocity in air is 2.4 times velocity of diamond. Means velocity of light in air is 2.4 times of the velocity of light in diamond, or you can do velocity in diamond is 1 by 24 times of the velocity of light in air. These 2 options are correct, and I will see whether which option is correct. Here, velocity of speed of light in diamond is 2.4 times. Velocity of light in diamond is 2.4 times of the velocity of vacuum. Velocity of light in vacuum. Velocity of light in vacuum is 4 times, 2.4 times. Means C option is correct. So, means velocity of light in vacuum or air is 2.4 times of the velocity of light in diamond. So, you need to use the formula, you will get the answer. Now, next question we are going to understand. A ray of light IM is incident on a glass slab ABCD as shown in figure. They have made a diagram. So I will make a diagram. See, this is the glass slab. They have shown this is the incident ray, and it will go up to this point, and they have shown like this. One ray go like this, one ray go like this, when one ray go like this, this is, and one more, this. This is S, P, Q and R. Okay. So this. I will tell you the answer because see, the question is very draw normal. Okay. So ray of light I am. This is I am. I am. Ray of light I am incident on a glass slab ABCD. ABCD. Okay. The emergent ray of this incident ray means which will be the emergent ray. Means when light travels, it bend again comes out. So this is the main funda you must know. When light passes through prism, okay. When light passes through prism, it goes parallel with the incident ray. Incident ray and emergent ray both are parallel. Both should be parallel because the velocity of light in air is same. And one more thing, when you see the prism, it go like this. Means emergent ray and incident ray are not in a parallel manner. They can be intersect. If you uh, uh, increase this or this, it will be intersect back at a particular point. So these are not parallel rays, but in case of glass slab, it is a parallel. So when you see, this is not parallel, but this line is parallel to this. So you can show a I am N and R. And I am N R is a path ray of light path ray. And when you go back, it will follow the same path. This is called principle of reversibility. So this ray is parallel to this ray, means this ray is correct. This is the emergent ray, not these are the emergent ray. So they have asked question. A ray of light I am incident on the glass slab ABCD shown in the figure. Okay. The emergent ray of this incident ray is NQ, NR, NP and NS. Here NR is parallel to this, so NS is the emergent ray. So this was the fifth question we discussed. Now next question, choose the correct statement with respect to refraction of light. Means we have four options, you need to choose the correct option. We will see. Okay. So choose the correct statement with respect to refraction. The frequency always changes when light enters from one optical medium to another medium. See, when light travels from one medium to another medium, its frequency remains constant. Wavelength changes, velocity changes. When it travels from rarer to denser medium, both decreases. Means this is not a correct statement. Absorption of light when it strikes the surface of the medium is refraction. Means absorption of light when it strikes the surface of the medium. When it's if it absorb means no light comes out. So I don't see this as a correct option. Third, the speed of light changes when it enters from one medium, optical medium to another optical medium of different densities. If two mediums are there having different optical densities, means the velocity of light changes. That is the correct option. So when light travels from rarer medium to denser medium, its velocity decreases, and the light travels from denser to rare, its velocity increases. Means I see the third option is correct. The speed of light changes when it enters from one medium to another medium. And last option is speed of light does not change when it enters from one optical medium to another optical medium. So you have four options. but the third option was correct because the speed of light changes when it travels from one optical medium to another optical medium. Now they have shown a diagram. AB is incident ray and C is the refracted ray. AB is the incident ray, A is incident ray. What diagram they have made? Air and water. Okay. So very simple question. See, I will show in book. You can see this is the question. When light is coming from this, it is bending. So when light travels from denser to rare medium, bends away from the normal. So B is a this is a not incident ray. C is the refracted ray. C is the refracted ray. A is the incident ray, and B is the refracted ray. No, C is the incident ray, and no, A is the incident ray and C. Yeah, A is the incident ray and C is a refracted ray. This option is correct. A is the incident ray and C is the refracted ray. Now, next question. This is not an objective question. Name the one factor that affects the lateral displacement of the light when it passes through a glass slab. Name one factor which is responsible or which affect the lateral displacement. This is a normal, this is the incident ray, and this is a refracted ray, and okay, this is the refracted ray, and draw normal. Again, it will go like this, and when you go like this, it will be parallel to each other. These two should be parallel. These should be parallel. Now draw perpendicular to this, perpendicular to this. This is the lateral displacement. If you increase I, okay, if you increase I means this increase I, it will go like this, means D will increase. If you angle of incidence increases, angle of lateral displacement D will increase. If decreases, D will decrease. Also refractive index. Refractive index of a material. Refractive index is high, means it will bend more. It will bend more. So you find this angle will be greater. So in a glass slab, the lateral displacement depend upon the refractive index of a medium and the angle of incidence. Okay. So in this question, they ask only one factor which is responsible for the lateral displacement. Does the depth of the tank of water appears change or remain same when viewed normally? When you see any depth normally perpendicular to surface, there is no refraction. So you can see whatever the depth is a real depth. But obliquely you can see the apparent depth will be up sudden at higher position. So we have discussed 10 questions and this one is last. How does speed of light in glass change on increasing the wavelength of light? How does the speed of light in glass change on increasing the wavelength of light? When light travels into the medium from any rarer medium or a vacuum, its velocity decreases. Now, here the velocity is directly proportional to wavelength. If velocity decreases, wavelength of light will decrease. If wavelength of red light is higher in air, in denser medium, the velocity of red light will decrease. So, in a medium, the velocity of light decreases and the wavelength also decreases of any color. So, we discussed near about 11 questions. Now, in next lecture, we will discuss 2-mark question. So, bye bye students. Have a nice time. God bless you all. Bye bye.